Okay, so in this session, we will look at how to write a program for the trapezoidal rule. Okay, so let's first understand what our objective is. So our objective will be given a function to find the given a function given a, b, and that is the endpoints of the intervals a, b. So given a function uh, the endpoints of the interval say a and b, and the number of points in the interval n, we would like to use the trapezoidal rule to estimate the integral of the function. That's the idea. Okay, so let's construct this using Python. So uh, like normally, let us define a function. We'll call it as trapezoidal rule and give inputs as a, b, and n. Okay, and again, we wouldn't like to insert the function as a uh, user variable. So let's define the function also. So let's define the function, let's say f of x, and let it return. Let's go with a simple function, maybe x cube plus 5. Okay, so let's see what does the trapezoidal rule, what is the formula for the trapezoidal rule? So the formula we know for the trapezoidal rule is h by 2 times, right, y1 plus yn plus twice everything else, right? That is y2 plus y3 plus dot 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 y suffix n minus 1. Okay, so basically the difficulty in writing the program for the trapezoidal rule is getting hold of this particular sum here. That's the difficulty. Okay, nothing else is really difficult, it's just adding. Okay, so for the variable n, to actually get hold of this sum is the difficult part. Okay, so we will call this sum here as s in the program and try to compute that sum. Okay, so what are the requirements? So first, we know that if we need n points in the interval, then the distance between the points, this thing would be ab by n, right, or b minus a. There are n points, we require n points uh, in the interval, then the distance would be b minus a by n minus 1. Okay, let's go with maybe m because n was used actually another way. In fact, our n is m minus 1. That is, we had taken points from x0 to xn, right? Since we had taken points from x0 to xn, that would have n plus 1 points. So n would essentially be m minus 1 in your formula, right? If you want m points, that is, your n would have to be, if you want m points, then, so let us write here, we'll give it a nice number of points in the interval. Okay, we could do this. So that's our third variable. So AB and number of points. So now we'll put number of points here. Okay, I hope everyone can understand that if you want to write, if you want to break an interval into equally spaced, n equally spaced points, right? Then the number of subintervals would be n minus 1. Okay, so h would be, that is the distance between two consecutive points, would be n. So h would be b minus a by. Okay. Okay. So so let's now try to find this particular sum. Okay, what is this sum going to be? So the sum is nothing but simply adding up. So the sum s. Okay, let us put this thing here. I'm trying to compute what this s is. So this s would be nothing but f of, right? It would be f of a plus h, because we are not taking f of a. F of a is y1. Okay, actually y0. Sorry, y1 would come in here. Okay, so it would be f of a plus h plus f of a plus 2h, which is the second point, right? Plus, let's say, dot 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 f of a plus n minus 1 times h. Okay. So this is what we are trying to add. So how do we add something like this? Okay, we don't know what n is, because the n will be a user input from the will be an input from the user side. Right? So how do we add up this? So there's a small technique which we can use, that is, we can use the while loop to do this. Okay, so we can set s as 0, and then while okay, so while you can see here h is the going from 1 times h, 2 times h, up to n minus 1 times h. So that suggests that we can use something like I equals 1, because that's what we want to add from. So while I is strictly less than n, right, because it has to go from 1 to n minus 1. What do we want to do? To s, we want to add f of a plus ih. That's it. Okay, so let's see, let's try to think what this will give us. So as we enter, first I will be 1, so s will become 0 plus f of a plus h. So in the first time, s will become a plus h. Okay, then we'll put I equals I plus 1. So now I will become 2. Then it will go back inside the loop. It will ask, is 2 less than n? If 2 is less than n, then s will become f of a plus h plus a plus 2h. Again, now I will become 3. Go back inside the loop, and you'll get s will become f of a plus h, a plus 2h, a plus 3h. Okay, and that will continue until this I becomes n minus 1. Okay, so when it's n minus 1, it will work, but once I becomes n, then it will exit the loop, because this condition will become false. Okay, so this is now going to give us, once we exit the loop, s gives us exactly what we want over here. Okay, s gives us exactly what we want over here, and now the integral will simply be, let us call it as I, capital I for the integral, right? So I will simply be h divided by 2 times y naught, which is f of a, right, plus yn, which is f of b, plus 2 times s. Okay, very simple this thing. Now we want to tell the user what it is, so we could return I. Okay, or if we want to actually tell the user what it is, then we could print out the estimated value for the integral. Okay, of course this has to be a string. For the integral is I. Okay, simple. Let's try to run this. Press F5, and like usual I will copy this here into the shell, and we'll run 1 to 2, and let's use 4 points. Okay, so the estimated value for the integral is 8.883. okay, let's think here. What is integral from a to b of x cube plus 5? The antiderivative of x cube plus 5 is x raised to 4 by 4 plus 5x. So at 2 you would get you would get 2 raised to 4 by 4, which you know is 16 by 4, that is 4. So plus 10. Okay, so what is that going to give us? You can compute and check. You will get okay, so I'll just compute and tell you. So the integral would be integral from 1 to 2 of x cube plus 5. If you compute and see, all of you can compute this. This is very easy. This would be the antiderivative we know is x raised to 4 by 4 plus 5x from 1 to 2. So that would be 16 by 4 plus 10 minus 1 by 4 plus 5. Okay, which is, let me compute, 4 plus 5, 9. So that comes out to be 8. Okay, so the value of the integral, the actual value for the integral is 8. Okay, now let's run this with higher values of n. Okay, here we took n, not n, but m in fact. The number of points are 4 here. If I run this with say maybe 100, because Python can do this work, we get 8.75. Okay, still closer, but maybe not close enough for you. Let's maybe run it with few more zeros. Okay, so 8.75. Oh, I'm sorry. The correct answer is 8.75. It becomes 9 minus 1.4. Okay, 9 minus 1.4 is 8.75. So that's the correct answer. Okay, so that's how you do the trapezoidal rule. So let's look at how do we do the Simpsons 1/3 rule. So it's the trapezoidal rule for you. You can try doing it on your own. It's a nice exercise. Let's look at the Simpsons. Simpsons 1/3. Okay, again we'll take the same entries a, b and n, or number of points in the interval. So in fact this whole starting part of the algorithm will remain exactly the same. So let's simply copy and paste it. Okay, only thing is the formula now changes. So let's see. Yeah, so in this case what is the formula? Okay, so there is a small restriction in Simpsons 1/3, that is, it is necessary for your n, okay, to be even. If you look back at what we did in the theory, you will see that to conduct the Simpsons 1/3 rule, or to perform Simpsons 1/3 rule, you would require n to be an even number. Okay, so it's nice to put a checker. In fact, you can put a conditional and give the user an input if they give you the wrong value, means if they give you something which n is not even, um, so number of points if someone had to put, they would have to put an odd number of points, because you know that odd minus 1 is even. Okay, so you could run a checker here, something like a conditional. So if how would you check whether n is even? You divide by 2 and check whether you get 0 or 1. So that would be n modulo 2. Okay, we have spoken about the modulo function before. So if n mod 2 is 0, then we will perform some algorithm. If it is not 0, okay, that is if n modulo 2 is not 0, then we should return, or we should print Simpsons, tell the user that this is not possible. Simpsons 1/3 cannot be done with these inputs. Okay, so what do we do when it's 2, when n is 2? So first of all, we should know what is the formula for the Simpsons 1/3. Okay, so what is the formula for Simpsons 1/3? It is 1/3 suggests that this is h by 3 times, so h by 3 times y0 plus yn plus, there is 2 times something, and there is a, so let's call this as s, and there is some, I think 4 times t. Okay, what is this s and t? So this s and t, okay, if you look back at the theory, you will see that this s and t is, yeah, so the odds go for 4. Okay, so this would be, okay, let me write 4 here, 4 here, and 2 here. So this s is, let's take this out as a comment. So this was y1 plus y3 plus y5, okay, up to, so let's go dot 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 up to, so it would be the last odd which appears. Since n is even, the last odd which appears is yn minus 1. Okay, so this would be our s. What about our t? So what is our t? So our t is all the evens, but not 0 and n. Okay, so that would be y2 plus y4 plus up to yn minus 2. Okay, so this would be a this thing, formula. So to find this, what we have got to do is take this part here as some s, take this as t, and then we do exactly the same thing. Okay, so let us try to conduct this method. Okay, so let us first initiate s as 0. The first one, that is sum of the odd suffixes, we will take as s, and sum of the even suffixes we will take as t. So initiate s as 0, t as 0, and take I to be 1. Okay, so let's see what we can do. So look at the while loop, and while I is less than n. Okay, so my idea is like this: whenever I is an odd number, I'm going to add it to s, and whenever I is a even number, I'm going to add to t. Simple as that. So we have to use a conditional, that is, if uh, I mod 2 is even, that is 0, or let's say if it is not equal to 0, or in other words equal to 1, right, because I mod 2 can either be 0 or 1. If I mod 2 is 1, then what I will do is take s and add to it f of a plus I times h. Okay, and else, what you could use an if else, that is, else will be when I is even. So that time I will add to t plus f of a plus I h. So let's try to think of what's going to happen here. Okay, so the first step, you will see s will be 0, t will be 0, I will be 0. So the first step, I will be 1. So since I is 1, it will fall in the first condition. So s will become f of a plus h. Okay, that is y1. And this will not be satisfied, of course. So t will still remain as 0. Then it will go back in the loop. Now, okay, we need to increase I. Okay, so now I will become 2, and now the second condition will be satisfied, that is the else, because if is not satisfied, so therefore else will be satisfied. So t will become f of a plus 2h. Okay, again it will go back up. Now it's going to come 3, and that will go to s, and then that will keep happening until I becomes n, and that's exactly what we want for s and t. And now what will be our final thing? We will take our I to be, I would be, that is the integral would be h by 3 times, right, f of a plus f of b plus 4 times s plus 2 times t. Okay, that's the answer, and we'll print let's use the same print as above. Okay, so the estimated value, okay, but of course this estimated value is using the Simpsons 1/3 rule. Okay, is this. Okay, let's run a program and see whether we have made any errors. Okay, again as usual, I'm going to copy and paste this. So here we have, let's run 1, 2. Let's go with the same ones, and let's put a 4 here. Okay, so we cannot use this. Why? Because this is an even number. We need to give it odd numbers to go. Okay, because n needs to be even. Remember that. So 1, 2, and let's use a 5. Oh, I have made an error here. Somewhere I have written IH, which doesn't make sense, right? I need to put I times H. So let's rerun. Okay, and you can see the estimated value for the integral is exactly 8.75. Okay, you can try to write this kind of code on your own. Okay, and see. There's actually no point of me increasing the value for n. I have just rerun this. Okay, no point of increasing, because at the first step itself we get quite a nice output. 8.75 itself. Okay, so this is Simpsons 1/3 and the trapezoidal tool for you. Okay, um, I will put this up also on your classroom if you like, so that you can have a look at the programs. Okay, we'll stop with this. Thank you.